You're welcome to learning quadratic equations by factorization method. Quadratic equations by factorization. Whenever you're asked to solve a quadratic equation, it simply means finding the roots to the quadratic equation. There are several methods of solving, but today's class is going to be restricted to solving quadratic equations by factorization method. So let's take an example. Assuming you are asked to find the roots of the equation 2x plus 3 x minus 1 equal to 0. Find the roots of 2x plus 3 x minus 1 equal to 0. If the product of these two numbers is 0, it implies that the first is 0 or the second is 0. So it's either the first is 0 or the second is 0. When plus 2 crosses over, 2x is now minus 3, or when minus 1 crosses over, x becomes 1. When plus crosses, it becomes minus, and when minus crosses, it becomes plus. To find x here now, we divide both sides by 2, giving the values as x equal to minus 3 over 2 or x equal to 1. In a case like this, you do not need to multiply the brackets. Just make each equal to 0, and the work is good. Let us take the second example. Says 2x squared minus 3x equal to 0. To solve a problem like this, the first step we need to do is to factorize the expression. In this, what do we have in common? X is common. So 2x squared divided by x gives 2x minus 3x divided by x gives 3. So if the product of these two gives 0, it implies that x is either 0 or 2x minus 3 equal to 0. After factorizing, equate each to 0. So x is still 0, or when minus 3 crosses over, 2x is 3. To find x, you have to divide both sides by 2, giving x as 0 or 3 over 2. So if the equation is of this form, you have to factorize first like we've done, and that gives you the solution. Let's take another example again.
Right.
The third example. If you're asked to find the roots of this equation, x squared minus 9 equal to 0. Here we're going to employ the concept of difference of two squares. Having x squared minus 9 equal to 0, we know 9 is a perfect square. So we express this as x squared minus 3 squared equal to 0. Because 9 is a perfect square, how? 3 squared gives 9. According to the rule for difference of two squares, if I have x squared minus 3 squared equal to 0, what that means is x minus 3, x plus 3 is now equal to 0. From the rule, x squared minus y squared equal to x minus y and x plus y. So, if I have x squared minus 3 squared, it is the same as x minus 3, x plus 3. Equating each to 0 now becomes x minus 3 equal to 0 or x plus 3 equal to 0. If minus 3 crosses over at this point, x becomes 3, or if plus 3 crosses over, x becomes minus 3. Meaning the roots will have x as 3 or minus 3. Remember here we had to employ the concept of difference of two squares, and the concept states x squared minus y squared as x minus y, x plus y. That's the principle we employed here. Let us take another example again. Our fourth example for today's discussion, this time, is a quadratic trinomial. What makes it a quadratic trinomial is the presence of three expressions. Assuming you're asked to find the roots of the equation, x squared minus 5x minus 6 equal to 0. This time it is a trinomial. Why is it a trinomial? Because we have three different expressions equal to 0, unlike the second and the third where there were just two expressions. So in trying to factorize this, it is usually best to multiply that of x squared, the quotient of x squared with the quotient of constant. On multiplying x squared by minus 6, you have minus 6x squared. The quotient of x squared here is 6, so we're going to look for the factors of 6. Looking for the factors of 6 means what two numbers do you need to multiply to get 6? And the factors you need to multiply to get 6 are 1 and 6, 2 and 3. Assuming you're looking for the factors of 12, for instance, the factors of 12 will be 1 and 12, 2 and 6, 3 and 4. But coming back to our area of concentration, which is factors of 6, we have 1 and 6, 2 and 3. So the next thing we need to do is to find which of these two numbers will give the middle number minus 5. I know both 1 and 6, 2 and 3 can give minus 5, so there's going to be further reasoning. Taking 2 and 3 for instance, what do I do to 2 and 3 to get minus 5? Minus 2 minus 3 gives minus 5. But minus 2 times minus 3 gives 6. And what we have here is minus 6. So 2 and 3 will not work. I am left with 1 and 6. What do I do to 1 and 6 to get minus 5? Plus 1 minus 6 gives minus 5. And plus 1 times minus 6 still gives minus 6. So the factors to use are plus 1 and minus 6. So we can go straight by saying this becomes x plus 1 and x minus 6 equal to 0. Since the coefficient of x squared is 1, it is easy to just go ahead and place in the values as x plus 1 and x minus 6. Remember, we said the factors that will work are 1 and 6, and the way it will work is plus 1 minus 6. So I'm going to pick to the first bracket x and the plus 1, then in the second bracket x and the minus 6. So if x plus 1, x minus 6 is equal to 0, it implies the first bracket x plus 1 is 0, or the second bracket x minus 6 is 0. Equating this gives x as plus 1 crossing over becomes minus 1, or minus 6 crossing over gives x as 6. So the root to this quadratic equation, x, is minus 1 or 6. We're going to take one more example and the last example for this discussion is number 5. Find the roots of the equation 2x squared plus 3x plus 1 equal to 0. If you take a look at this fifth example, it is still a quadratic trinomial, but now the quotient of x squared is no longer 1. There is now a number in front of x squared. We can no longer go express the way we did the other time. But as usual, we're still going to multiply the quotient of x squared by the quotient of constant, giving us 2x squared. When you multiply 2x squared by 1, it gives 2x squared. What are the factors of 2? We know the factors of 2 as 1 and 2. No other factor again. So what do we do to 1 and 2 to get plus 3? 1 and 2 becomes plus 1 plus 2. And of course, if you multiply, you still get 2. So the factors are plus 1 and plus 2. This time, because there is a number in front of x squared, we can no longer go and write x plus 1, x plus 2 again. It is no longer possible to go this way. Why? Because there is a number in front of x squared. So what do we do at this point? We are now forced to place in this as 2x squared plus 1x plus 2x plus 1 equal to 0. It was previously 3, we've tactfully made it 4. So this 3x has been replaced with 1x plus 2x. How? From this and this factor. So I'm now going to place them into 2 segments evenly divided. Checking the first half, what do we have in common? If you check, x is common. So 2x squared divided by x gives 2x plus x divided by x gives 1. Coming to the second half, you will check, what do we have in common? If nothing is common, then plus 1 is common. Because nothing is common, plus 1 is common. 2x divided by 1 gives 2x, plus 1 divided by plus 1 still gives 1. Whenever you're solving a problem like this, whatever you have in the first bracket must be equal to the second bracket, or else there is a mistake. You go back to check. So at this point, I'm going to factorize again by picking what is common, 2x plus 1. What's left outside here, x, and what's left outside here, plus 1, equal to 0. This is taking us back to the way the first question was. So at this point, it's either 2x plus 1 is 0 or x plus 1 is 0. Making x the subject and plus 1 crossing over, 2x is minus 1. When plus 1 crosses over, it becomes minus 1. On dividing both sides with 2 gives x as minus 1 over 2. On the other side, when x plus 1 is equal to 0, if plus 1 crosses over, x is equal to minus 1. So the root to this equation is minus 1 over 2 or minus 1. I believe you have understood this explanation. This is just solving quadratic equation by factorization. Please like and subscribe to my channel for further teachings on quadratic equations. My name is Tari, your teacher. Thank you.